Welcome back, Generals, to another Let's Fix Generals 0 Hour to make the best game ever. Good, so, last session we worked on the buffered IO. There's still something to do where we dropped off, I think the delete on close thing, right? Yeah. Before we continue with that, let me stash the current changes. Yeah, stash. And instead, we finalize this one here, because we do have an approval on that one. Let me see, review approved. This one here. And have some improves the buffered IO in game engines file system. Okay, so there was one note here from me that this was not meant to be uncommented. Yeah, I don't know why this happened. So I think we just put it back to what it was before. Reverts, uncommenting. Let's see. Maybe we should say local file. Enable improve buffered IO in local file. Fixed. On that note, I think oops, label performance. Multi-threaded. Of unnecessary. Okay, we can add these two milestones. Okay, then we have to wait until this is done. And then we can merge this. While we wait for this, let's see if there's anything else we should look at. How about this one here? It's not clear to me what the root issue is. Sometimes beacons are not associated with any player anymore. Beacons are not associated with any player. Bug fix. Prefix. Prevent runtime crashing when a beacon is no longer beacon. Where's this coming from? Find object. And a beacon is no longer associated with a live player. Prevent runtime crashing when a beacon is no longer associated with a live player. I wonder, could it be Could it be that this crash, that this problem occurs when a player is defeated? Could it be that this problem occurs when a player is defeated shortly before a beacon message request is processed? So basically remove. So basically remove beacon. Get killed within 10 frames. Crash. Player removes beacon. Player gets killed within 10 frames. Crash. I have not looked into that. The sample image above is was copied from efforts of J. Marshall's fork. Game fork. Marshall's fork. Okay, so this one has built, yeah. And that was fast. Okay, let me double check that one more time. Here we enable this shit. Here it's enabled. Buffered IO. Okay. Enable and improve buffer.io and Logify to reduce its cost by up to 90%. Okay. 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 Delete branch. Okay, and with this in place, I will now update this other branch here, this guy. Rebase. And there's a conflict. Oof. Okay. Okay, it's not ideal. How can we repair this? We create a new branch. Create a new branch. Then we go in here. We reset current branch to here, hard reset. And then we cherry pick this guy. Okay. Then maybe rename it. Doesn't matter. Local file. Okay. Push. Implement custom buffer options. Implement custom buffer option. Yeah, okay. Right, so there was this question here. So the question is, should we only use line buffering if we write? Let me ask our friend ChatGPT. Does it make any sense to use line buffering for reading? Yes, line buffering can make sense for reading, but it depends on the context. Here's when and why you might or might not want it. When you set that on a stream, depending for reading, it means the input buffer will be filled from the file up to and including a new line or until the buffer is full. So with that, the system will try to read at least a full line, not just one character, which can be more efficient than unbuffered. When line buffering for reading does make sense, reading from interactive input or terminal. Let's see. Text line by line from a pipe or socket. Predictable reads aligned with two new line boundaries. Reading binary data. Reading large amounts of data. Don't need to process data line by line. Reading from a terminal. Reading text line by line. Reading text line by line from a pipe or socket. And using fgetS. fgetS. Do we have it that implemented fgetS? We don't. Let me see if there's any users of text in the code base. Game text is reading with text. Script engine as well. So what do we say? Accesses file as text data with full buffering if neither text and binary are set. As text data with full buffering. maybe we should have a how about we say, how about we add new flags for the buffering? So here we have streaming. So how about we say access file as text data, as binary data. Yeah, maybe we should keep these separate. Do line buffering. And then full buffering. Maybe make it shorter, line buff, full buff. Then we say here node accesses file with full buffering if neither line buff and full buff are set. Yeah. Then here we remove this, and here we say access file with line buffering. Access file with full buffering. Line buff, full buff, okay. Access file with full buffering if neither line buff and line buff. Okay. Maybe we add here the super hackers add feature adds line buff and full buff modes along with buffer size. Alongside new buffer size arguments. Access file with line buffering. Full buffering. Okay, and then Okay, so by default, it will always use the full buffering, yeah. But we can opt into line buffering, yeah. Okay, access file with line. Okay, then we need to go into local file, open. And there we say, so we don't need text, we just say const bool full buff. Maybe we do it down here. We can just say maccess full buff, no, line buff. Yeah, I think that makes more sense. Yeah, that we can explicitly say whether we want line buffering, because there is a case to make that maybe we want to treat a file as text, and either use line buffering or not use line buffering. Yeah. Uses line buffering. Uses full buffering. I think we can remove this here. Or we just keep it. It's redundant information, isn't it? Streaming, only new. Text bar right trunk. Line buff. Yeah, I think that makes sense. Maybe we should simplify this file.h. Where is it? Here. Add slime buff, full buff, molds, and new buffer size argument. Buffer size arguments for file open. Three fails. Oh, that's not good. Okay, cool. Let's run the game once to see if things work. Go to local file. Let's put a breakpoint in here. And that should always be buffer mode 0, which is full buff. Yeah. Okay, cool. Okay. I'm going to disable this. Okay. Improve, let's say add lime buff and full buff modes. After some thinking, I concluded that it better be separate from text and binary. So I added new modes, line buff and full buff. So user has full control. So by default, a file always opens in text mode with full buffering. It's kind of weird, isn't it? But it's consistent with what fopen does. Yeah. Text mode, full buffering. Weird, yeah. Be separate from text and binary. So I added new modes, line buff and full buff. So user has full control. It's better separated. This way, caller has full control over the behavior. Maybe local file. Probably remove the dot here and here, because the other lines also have no dots. Well, they do here. Polish comments. Okay. Good. Anything else? I think that's good. Rebased the main branch. Good. Now with that out of the way, let's get back to this guy. I think we can delete this guy here. Now we go here. And I think I think we actually delete the branch as well. Then we go to main. We delete this one. And then we create a new branch. Okay, and then we do stash pop. Good. Okay, so the question is, what do we do with this delete on close? It is quite a bit tricky the way that it behaves. If we call it just in the wrong order, we shoot ourselves in the foot, right? So if we set it before we call open, then there can be a fail condition and we can invalidate it in mysterious ways, unexpected ways. How do we do with this? It would be nice if we can set this delete on close anytime, right? Just in advance, before we open. So if we call RAM file open, that never calls close, yeah. What is the other one? Dockerfile streaming archive file. Streaming archive file. Open, true, okay. If not open. Yeah. It's really how do we deal with this? I don't know. Okay, so we need to think about what we do with the local file. Down here, where it causes close on open. And it only does it because we have this here, right? If it wasn't for this, we wouldn't need to call close. But maybe what we can... Well, the problem is... delete on close. So if a file is not open, maybe what we can do is we can say we're not allowed to call delete on close when... I have another idea. Maybe we can defer this. No. No, we can't. Or can we? Close. Okay, so this one option, at least we can say we can prevent the user from calling delete on close before he called open, right? There we can say to at least like tell the user, if you do this, bad things can happen. That's at least an improvement. Okay, but can we? So that would be in where's it? Delete on close. I think it's in file.h. Yeah. Delete on close. Yeah, this one. All right, so currently it just stupidly sets true here. If we set this, and we can't even set it to false again. It's a one-way street. Okay, so what if we said we can call this anytime, but we say I only actually delete it if it was. Well, we're not supposed to call close if a file wasn't opened yet. Close. What did this function do before? Let me see. So before, that's also weird, right? So previously, if open would fail, it would still call close afterwards and then delete instance. Why do you have to call close when the file hasn't even opened? It's actually redundant because inside open it already calls close. So that doesn't make sense. Okay, but it then does delete instance. Okay. Yeah. So if you go back to this code here, file open. This one. So the previous code did this. So let's say we remove this here again. Let me put a breakpoint here. Here. Oof. Okay, I get some spam here, but it's private messages. So We'll have to read it after the video. Play and all the hassle over the base type conversion macros, and turns out it makes no difference and you only need the type conversion and none of those fast functions. The fast functions, if anything, just end up adding overheads. And the result is no different without them. Fast func 1, fast func 2. Good, so that has compiled. So I think what we can at least do here is we can remove this close for starter, because that looks like redundant, right? It should already be closed. Let's look into that. So a file is null and it is not open. Yeah, so that does nothing. It's a Win32 local file, which is a local file. Yeah, so, okay, so it's fair to remove this for starters. Right. But now it would be nice to say delete instance. It is weird that you... Close. Delete on close. I have an idea what we can do. Local file. Maybe we should say let me put a breakpoint here. It's good that we have this test case already on regular game boot, so it's easy to test this thing. That's very much appreciated. Okay, so I don't know what exactly has failed here, but we have a file open, right? No, we don't. Okay, so it tries to open some file that doesn't exist. Okay, and file is null. Okay, then we call into close. And then it doesn't need to clean up anything here, but it goes in here and it thinks that the file is opened at this point. It thinks that a file is open. Okay, how does the rest of this class look now? So there's a name str. There's an access. open. It claims it's open, but it's not really open. It just wants to be open, right? So it opened when we called this open here, but that's not really the real deal, right? I think what we need is a function here that does the same thing here, but without this. Close. Yeah. You don't close. Well, let's think about it. Is it expected that? No, it's not expected. If you call open and it returns false, yeah, then it can delete itself, but it may not. So you don't know. You don't know. Yeah, that's a problem. You don't know if it actually has deleted, right? And you can't check because it's deleted, right? So if a function, yeah, okay, it's definitely broken. It's definitely broken, but only if you set delete on close before you call open. Otherwise, it's not a problem. Okay, how do we? So it must be consistent in one way. Either it always deletes itself when it cannot open, or it never does that. One of these two. But it can't be a mixed bag. Yeah. Okay, I think we can probably make this assumption. Yes. But then what do we do now? We need to it's not clear. I would say it should never delete itself in open. Yeah. It should never delete itself in open. Even if we have it delete on close set. You need to manually delete it if you wanted to. Otherwise, a call to close can close it. Yeah, I think that's a better assumption here. Yeah. Okay. I'm happy with that decision. Okay. How do we implement that? How do we implement that? We open. So if it's open, basically we must not call this function here. Okay, then how about in a local file? Local file. We have open. And in here we call close down here. Okay, so how about we create another close function? So this is a regular close. Yeah. For each successful, yeah. Then how about we add a new function and we call that make it a protected yeah, close close without delete. How about that? Voids. Then we add that here. Then we also need another function and call that void close file. Close file. And so in the close file we call this here. Yeah. Then we call close file here. And then here, close without delete, we call close file. And then how about we put that here? Close without delete, we move this up here. Close without delete. So that we call close file. And then we need to basically do this here without this. Do we just copy it or? Maybe what you can do is we also add a protected here voids close without delete. Okay, that's it. We can enable this breakpoint. Okay, and then in here, close without delete, we then call file close without delete. There we go. Okay, and then we have this close call in here somewhere. Delete on close. Delete on close, close. Should delete. And then here we call close without delete. Must not self delete here. Must not self delete in here. Instance must not delete itself. In this function. Must never. Super hackers. Add tweak. Let's say can put fix. It's not a bug fix because it was not user facing, but it is like a technical fix. Okay, close without delete. Okay, and so there was this other place which makes a big complicated logic here. So it does different things depending on delete on close. Why not simplify that to call delete on close. File open this. It needs to do different things. Close. There are two ways we can simplify this. We can say, so this is the original code. I think the way we can make this simpler is we remove this. We have delete on close. And then here so either we set ourselves to delete on close and then call close, or we just call this delete close without delete, and then we call delete instance. That's simpler. That should work. If ramp file open, else ramp file close, delete instance. Why does it need to call close here? What is that doing then? It's deleting a buffer, but it wouldn't. It would do that anyway, no? Here in ramp file. I think we can remove this, yeah. I think this will work. Now, if we go back to if we go back in here, that now means we should be able to set delete on close here, and then we should be able to remove this stuff here. Let's put a breakpoint here. Actually, we already have a breakpoint in there, so that should be good. Let's put a breakpoint anyway. Okay, I think this will work. So we can set delete on close swiftly anytime now. It shouldn't crash anymore. If it fails to open, then we manually call delete instance, of course. Yeah, I think that's good. We can make one more improvement to delete on close and make it like with the argument here that we can set it or unset it. All right. Okay, so the file is now close. We have set delete on close, but it's not deleted yet. So it will delete now and set this to null, and we're good to go. Yeah. Now we have here a case where the RAM file is closed. Delete on close is now false. Data is already null, and then here mopen is already false as well. Okay. Okay. Convert to RAM file. Okay, let's take a look at this guy. So we create the RAM file here. We have a delete on close is true. So we set this. Then we close this without a delete. So we first close the file here. Yeah, that's fine. And then we close without deletes. Open, blah, blah, blah. Okay. Now we didn't get down in here yet. Exit. Okay. Okay. I think that makes sense. And then so what we can now also do is here the RAM file close. Here. All these cases where we call now delete on close. How about close? Close. Close. How about in the RAM file we introduce the same kind of concepts? We have here protected, and we put I don't know why we have void close data, or close without deletes. And then here we also say close, no, close. And here we do a file, close without deletes. Okay, so we can do that, close without delete, and then on the destructor we also call this here close without delete. Here we do the same, close without delete. Remove that. Now we have the same here. This is RAM file. RAM file. What does it do on close? Just calls file close. Okay. I would say we simply create another protected voids close without deletes. Close. File close without delete. Okay, let me search for all these occurrences. Okay, it looks good to me. It does make a lot of sense, I would say. So we now always close the file on destruction. So I think we fixed a bunch of things. I already lost track of all of them. But so we fixed the issue that it would self delete on, if you call delete on close before you open eventually. It would self delete and then you would have a problem. The other issue was that local file would not close its internal file if you actually called close. It would only do it in the destructor, which eventually would be called if it delete on close was true, which I think is always the case in the engine, but if it wasn't, then it wouldn't properly close at the right time, right? Yeah. Okay, any other problems? I'm thinking that maybe this delete on close file it would be kind of nice if we could say bool delete. Bool deletes del boot del bool del. Delete on close. How about we just say enable? Delete on close, enable. Enable, enable. Okay. And we say by default it's true. Okay. And then that's it. That's it. Yeah. Okay, so now you would be able to say, hey, I don't want to delete on close. Yeah. So if you are setting this maybe there's a case to make that maybe you only want to activate it, you never want to deactivate it. Could there be a reason why they said we only want to enable it but never disable? Other than there was no use case for it. Not sure. I mean, there's no urgent need to change it, so maybe we just leave it the way it was originally. I can't think of a reason now why would why we would want to set delete on close to false after we have set it to true. So maybe we just leave it as is, and only if there is a use case, then we change it. Yeah. File object no longer valid after this call. File objects may no longer be valid after this call. Well, I can think of a use case where we would want to deactivate delete on close again. Like if we had a reference counted file object and the reference counter would reach 0, then we would close the file. But currently we have no way to check whether delete on close is activated, so we would need to set delete on close to false, and then close, and then delete, right? Yeah. So there is a use case here. We are not using that right now, but there is a use case. So maybe we do. So maybe we do put a bool then here, bool enable. Yeah. Default true. Ah. It goes here, not there. Okay. Yeah, this works. Convert to RAM file. Read entire and close. Okay, I think that's already good enough for status. There's probably more we could improve, but I think I'm pretty happy with this. Yeah. Protected. Why do they put the members up here? What is this? It's a little bit unholy, isn't it? Yeah. Okay, but this should work. Yeah. Okay, so we have now, so we have a local file, close without delete. We have RAM file, close without delete, and streaming archive file. Let's put breakpoints on all of these guys. Yeah. So local file, we go in here, close file, and it is already closed. How about conditions open equals true. Yeah. Okay, it never hits that case. Interesting. Okay, that's interesting. I thought that there would be some case where it reaches in here when the file is still opened. Which is maybe the reason why it never was a problem to begin with. Yeah. So before there was, so before it called file close, so previously the close function also only called file close, but it didn't actually close. Yeah. And now it does call close. Okay. This is oh my gosh. So previously, if a file would have been deleted without calling close beforehand, then it would have called this here, and if then delete on close was true, then this would have nuked the program, essentially, right? Because it's already deleting, and then in here it would try to delete itself again. Yeah. So it's quite a miracle that this never crashed. Oof. I'm astonished by how bad this code is. Jesus Christ. Oh my gosh. Yeah, I'm really surprised. We have this guy here. Maybe we call here close file. Maybe not close file. Maybe we shouldn't call this close file, but delete data. Free data. Do the same here. Data. I can keep a. Actually, we don't even need this free data. We just put it in here. How about that? Just like that, and then we remove this function here. Simple enough. Okay, cool. I like that. Okay, so if we didn't make a mistake, then things are good. Okay, let's take a look one more time. Here we still have work in progress code. Okay, so if it does not open, then delete instance and files. Now, yeah. Now, what we could also, I mean, actually, we could keep this else here. Yeah. Yeah, maybe we just keep that. And we just remove the close. Yeah. Now here in the streaming archive file, we could also simplify this and just call this directly in the destructor. Streaming archive file. We remove this here. And this here. I think they wrote it like this, that it's no longer valid after call because the way it currently is set up is that this condition is meant to be always true if you create it through the file system. So maybe we keep it, the comment, the way it is right now. Now, currently we do nothing that will set this to true. So I'm inclined to revert this here as well and only add this when we actually do need it. Yeah, I think that's a better idea. So I will reset that again. Okay, but this one we need. Close file. Close without delete. Yeah, I think that makes sense. Yeah. Good. I was a bit worried at the beginning that I wouldn't be able to figure this out, but now that I see it, it actually makes a lot of sense this way. Okay, cool. There's still one more case in STD local file system. Hold on. That note. Okay, so we need to replicate the same change to a STD local file system. This one. Here we have an error. Local file. Should probably remove this here. RAM file. Okay. Okay, so this is core fix fix code fix unsafe code, fix unsafe logic in file system regarding deletes, regarding closing and deleting files. Fix unsafe logic in file system regarding closing and deleting files. Okay. Then we need to write a text for that. Okay, so this change fixes fixes unsafe logic in file system regarding closing and deleting files. Identified problems are local file does not close the internal file on close, but only in the destructor. Local file does not close the file handle on close, but only in the destructor. Calling delete on close before calling calling delete on close before calling open is dangerous. Let's say calling, no, that's incorrectly. Calling open after calling let's say calling local file open after calling local file delete on close is dangerous because inside open is a call to close which is a conditional call to close, which can then delete itself, and it is not visible to the outside, to the caller, and that is not visible to the caller. 1, 2. And the third problem was, I already forgot, the delete on close. Calling, let's say, destroying destroying local file, RAM file, streaming file, streaming archive file, right? Streaming archive file. Yeah. Destroying local file, RAM file, streaming archive file after calling delete. After calling delete and close, but not calling close is fatal because it would delete itself during destruction, because it would attempt to delete itself during destruction. Yeah, local file does not close the file handle on close, but only in the destructor. This is bad because local file on that note, we should probably there's another issue here. If we would call open, is open public or not? Let me see. In file. File.h. Yeah, it is public. So if we were to call, let's say we have a file pointer and we now were to call open again on that thing without close, then I would just leak the file, right? Do we really need this comment here? Instance must never delete itself. I think I can remove that. I'm thinking that we should probably call close without delete up here. Maybe we should have this comment here, yeah. And then we can say here, we say here, Superhacker set tweak. Close file, just in case. then we would need to call that in RAM as well. Yeah, close. What does this do? If M open false. So we cannot. Okay, so actually it will fail to open. I think we don't need to do that here. That's fine. That's fine. Let's reset this. Okay. Okay. Identified problems are local file doesn't close the file handle on close, but only the destructor. This is bad. Well, this would cause memory leaking if one were to call close and then open with the same file pointer. If we were to call close and then open, at all. Destroying local file, RAM file after calling it, but not calling close is fatal. Can we assign code reviewers, milestones, stability, fix. I'd say it's minor because it's not really a runtime issue. Fix minor. say deleting. Oh, we have this here still commented. Now, that also means that this is now obsolete, right? Which means we should now get a breakpoint here, a hit, right? Let me see. Close without delete. Yeah, so it will delete itself here. And then close without delete. Delete on close is true. I do wonder, is it necessary though to call this at all? Like, what is the purpose of this? Like, why do we need to change the name? We just close ourselves. Like, set name is actually allocation, right? Now thinking about, I think we don't need to do anything here. We don't need to. Actually, it's not true now. We would need to call close file. We would need to call close file. What do we do in RAM file? I think we can simplify this here. So, close without delete is certainly needed in the open file here at the end. This is required, yeah. But in the destructor, it would be enough to just call close file, right? Because no one cares if we call this here. No one cares. Like, it just set some members here, but we delete our own instance, so that will be gone. So wait. So in a destructor, we only need to call close file. And so on RAM file, I don't think we need this function here at all. Close without delete. Instead, we just call this in the destructor. This here. There we go. I'll remove this. I'll remove this. And this. Maybe it would still make sense to have a protected close file. And then a close file, we do this. Close file. Just so that it's the same as it is in local file, conceptually. And then in streaming file, streaming archive file, we don't need to call this at all. Like, who cares? Ah, no, this we need here in close. But here we don't need to call anything. Let's double check RAM file. Close file. Let's put a breakpoint here again. M open. And now we just close the file because we have a file here. But other than this, we don't need to do anything. So it still now claims that we have a file here open and that we have, yeah, that it's open. But we don't do anything. We just delete it. Oh shit. Then it crashes. Oops. That is unexpected. Oh. Oh. There's another one. Close without delete. Remove that as well. How about that? That's extra tricky here, this code. Extra tricky. Okay, now we have this close file. We go in here. Okay, blah, blah. And now we're good. Okay, cool. That works. So we do have some hits here. Convert to RAM. Always goes through here, yeah. Okay, cool. I think that works. Let's see if we have any memory leaks here. Additional ones should be 21, 56 now. Let me restart. Twenty-one. Okay. Okay. Then we say for the simplification, simplify code, simplify more. I think I can put this under stability. Not really. It wasn't used incorrectly, so it wasn't a danger for stability, but it would be if used incorrectly. Yeah. Yeah. Well, I mean, it's borderline stability. Yeah, I don't know. Okay, I think that's good enough. Do we give it the stability label or not? I don't know. It's not. Yeah, it's a theoretical stability issue. It looks like the original game never ran into any of these problems. They are there, so if we would do a mistake, it would have a problem. But the usage, maybe I should clarify this. The usage of this code never ran into any of these 3 issues. Or say, the usage of this code, luckily, never ran into any of these 3 issues. So this is no practical stability concern. Okay, cool. Then I will take a break here. And I wish you a great day or night. Until next time, goodbye.